Oh, is that the key?
It's, ooh.
Oh.
Look, there's people.
Hello. I learned something very cool. Well, I knew it, but I was reminded in 2 specific instances in the last 20 minutes, in the break, of the power of smiling at people. As I was going past 2 people, they smiled at me, I smiled back, I felt better, I suspect they felt better as well. So, you know, top tip, smile at people, it really works.
Yes.
It's cool.
For instance, smile at us, right? So it's always great to catch up. Whenever I come to the UK, I try to catch up with you on stage in front of
Yeah, so apologies to those who wanted undivided Mads, as it were. This was me joining Mads at the kind of last minute, or Tuesday, I think it was. So thank you very much to Mads for inviting me up here. So I get to do a versioning talk tomorrow instead of a C# 8 talk, because I figured that there's only so much C# 8 that one conference can have. It's a pretty high level, but
we've been pushing it at this conference. We already had 2 talks with Bill Wagner yesterday. And
how many of you were at those talks, or at least one of them? Huh. OK, maybe let's do it the other way around. How many of you weren't, so therefore, OK, still a good number.
Good.
So it's probably, we shouldn't entirely skip the Null thing. If it was like, you were all here for Null, you don't want to spending 10 minutes going over exactly the same stuff.
Right, but now we will.
Yeah.
Because 2 hours ain't enough.
Yeah.
So anyway, do you think they know who we are? Should we introduce ourselves? Or?
Yeah, go for it. Go for it.
OK, I'm Mads Torgersen. I'm the lead designer of C# at Microsoft. And
I'm Jon Skeet. I'm a C# fanboy, basically. I'm a staff software engineer at Google. I work on the Google Cloud Platform .NET client libraries. But the reason I'm up here is because I'm a C# fanboy, basically.
Good. So with that cleared away, we have a lot of intro slides here. No, actually, that's it. We have Visual Studio. So what we're going to talk about is mostly, what's coming in C# 8. We're going to play with the latest preview that came out last week. Well, some of it came out this week, the framework parts, and we're just going to play with it. I told John it's OK that he comes up to my keyboard and types.
Although what tends to happen,
as long as I watch him doing it.
Yeah, when I come up and type in preview builds, I tend to end up finding compiler issues just entirely accidentally. I'm a massive corner cases, and
now
seems
you
to happen,
tell me.
But.
OK. So we're going to do that. We're going to go through some of those features, and then towards the end, we can talk about some of the things that aren't in preview builds yet that we still imagine being in there, and what's new. What are we imagining for the further out future of C#?
Cool.
So does that sound good to you?
Let's go for it.
OK. So piece of code here. I have an array. I'm creating an array of people, persons. We can see from the type, hover type here, and I want to just go through and print them all out. So I have a little display method here that prints the first name, first letter of the middle name, and the last name. So that is totally basic stuff for each var person in people. Display it. Display the person. Boom. All right, what happens? I deliberately didn't show very much.
Yeah, I mean, we haven't even shown the person type, but
No,
you can kind of guess some of what's going on.
There we go. Come on. Jon Skeet. Oh, boom.
OK, do we still have the output so we can? Yeah, it should still be there.
Yes. So apparently it's allergic to you.
No, it got me. I'm fine.
Oh, it's just you.
Yeah.
All right.
I like this, a compiler that only
likes
happened?
Me. Let's go back here and see. Oh, we got a null reference exception. Why did we get a null reference exception? Well, person.middlename.get returned null. Oh, okay. Oh, someone, me, did not have a middle name. So if we exit out of the debugger here and actually look at that array, yeah, sure enough, you're the only one in here who has a middle name.
I like being special.
Yes. Well, probably more people have middle names, but I didn't know their middle names.
But null reference exception, it feels like there's a feature for that.
Yes.
It's like the new version of there's an app for that.
So how could we have avoided this? How could we have avoided shipping this app to 1 million people and then it crashed? That's what nullable reference types are about.
OK.
So the idea being that we can, there are things that you can't express today in C# that maybe we can let you express, such as, hey, is this thing supposed to be null or not? Right? We can't say today, so we have to sort of guess.
Right.
Should I be checking for null? Should I be handling null specially?
Or use alternative approaches. So in NodeTime, I'll probably mention NodeTime a bunch. It's my .NET date and time library. And I sort of prepped for nullable reference types before they were even on the horizon by I have an attribute on every public method that returns a reference type saying whether or not it will return null.
Right.
And I actually have a test that makes sure that every public method has either can be null or should not be null. And
Right.
I'm trying to currently work out with nullable reference types, should I get rid of those tests or should I assume that if I've just written one thing, it's kind of OK, and that's what I meant. One thing about having to put attributes in, it makes you really, really explicit. And as Mads said yesterday, there was an option of considering having this is a non-nullable string, this is a nullable string, this is a no one's decided string. There's something to be said for always being explicit.
Yes.
I fully believe that classes should be sealed by default rather than unsealed by default, but I'd also have been fine with there being no default and saying you have to say, I want to seal, I want to unseal. So always think about not just can I express intention, but am I forced to express intention?
Yes. So the challenge here is that the world is full of code. It's full of use of reference types, and some of them are supposed to be null and some are not. Should we make you rewrite all of that code to be explicit about your intentions in both directions? Or should we just make you rewrite half of that code? And we opted for only making you rewrite half of that code. So essentially, the idea is that we can now, and I'm now going to go and do it, we can now turn on, so it's a feature that you have to turn on, and then it's going to essentially up the level of scrutiny of your code as sort of, typically the first way you'll meet this feature on existing code is you turn it on, and it's going to start complaining about things in your source code, and it's going to complain nicely. Let's turn it on. One way you can turn it on if you just want to try it on a little bit of your code is you can say nullable enable as a directive, and then it turns it on in your code. But you can also turn it on for the whole project, and I think.
And that enable is not the only option. And this is something that I haven't looked at in detail, but you can put that in the project file instead. But there's enable, there's warnings, there's all kinds of different interactive aspects of how this feature is going to be enabled, because it's kind of different to, there are various ways in which nullability is, or nullable reference types are different to other new C# features. It's not really an on or off thing. Yeah, sorry, the little conversation that's going on here, the tag name in MS Build has changed kind of recently, so no one has it in muscle memory yet.
Right. I don't have it in any form of memory.
So there's enable, there's various other things. And the reason that this is weird is it depends on what the code you're calling is going to be doing and whether that knows about nullability. And it depends on what's calling you, and there are lots of different options because this is part of an evolving language. If you come along to my versioning talk tomorrow, you'll hear a lot more about it's really hard to plan for change and work out what counts as breaking and what doesn't, and how we should evolve things. But that's been, I assume, one of the tricky things in terms of design. Yeah.
One problem with this feature is so as I said, I turned the feature on. You now see I have a warning in my code I wouldn't otherwise have, which says that this constructor is not initializing all the non-nullable fields of this class. Well, up until very recently, there were no non-nullable fields in this class because that didn't make any sense. So I'm essentially making the language stricter. And when you do that, you kind of have to give people a chance to ease into that. So it's not just about an evolving language, it's also about evolving source code and getting to this on your own time rather than C#8 saying, OK, from now on, you're forced to do this. So there's one big switch, and once you turn it on, you're lost in a sea of warnings until you clean it all up.
And it really is a sea. I mean, don't be fooled by the fact that Mads has turned this on for the one file, and there's one warning. I decided I made a mistake in turning it on in all my no-time projects, other than the 2 I'd already done this week, and there were like 1,000 or 2,000 warnings, and that's just really, you don't feel you're making any progress. So I then did it a whole project at a time, which was still faced with a lot of warnings, and it can be quite dispiriting. So my experience of these warnings is you're playing whack-a-mole with them. So you fix a warning, and that gives you 2 more warnings.
Let's try that.
So if you get that experience as well, don't think you're doing anything wrong.
Okay, so let's do the whack-a-mole.
Yeah.
And so the first half of the feature really is that once you turn this on, reference types become non-nullable. You're no longer allowed or supposed to have null in there. And when you do, you get a warning. So, oops. And it's being a little sneaky because I'm not assigning null to anything anywhere, but now because these strings here are all reference types, and so they're now not supposed to be null any longer. And because I am initializing 2 of them here, so that's fine, but the third one I'm leaving as null, which is the default value that it gets, and so I get a complaint about that. You should initialize non-nullable properties. So let's initialize a non-nullable property. We were saying middle name. We just say it's equal to null, and now we initialized it. And now the warning goes away, but I get another one. Whack! That was one mole. You can't assign null to it either.
What are we going to do now? So at this point, you need to think. And this is one of the scary bits about nullable reference types, is a feature that makes you think. Do not be scared of this, but be ready for it.
Yeah, the point is, I don't want it to be non-nullable. I want to be able to express that people don't have middle names.
And the compiler cannot possibly know that.
Yeah.
You could write a Roslyn analyzer that says, fix all my nullability warnings for me however you see fit. Okay? And goodness knows, in this case, it's feasible that a smart analyzer could decide, oh, well, you're not passing things in. I will make it comply with everything you're currently doing. Mm-hmm. But that's kind of guesswork that really is thinking about your domain. In this case, we want the middle name to maybe be null.
Yeah.
But I wouldn't trust any tool that assumed that for me.
So this is where the new syntax comes in. This is where we're now allowing you to say explicitly, this is where you're explicit about your intent.
Right.
Actually, middle names can be null. So let's put a question mark on the reference type and say this is a nullable string. Okay, and this is the new, syntactically new thing here.
But I want to point out how this is not. So this looks really familiar. If you've been asked what syntax should be used for a nullable reference type, you might well have guessed that, right? And you might think that's fine. That just means it's equivalent to nullable string. Not at all. Okay, this is a different kind of nullability, and you need to think about types in a different kind of way, and that's one of the difficult things about the feature. This is not a simple feature, but it's a fantastic feature.
We chose syntactically to use the analogy to nullable value types. So question mark means nullable, lack of question mark means non-nullable. But what that actually means, one level down, is different.
Right.
For value types, value types don't already have a null in them. So for them, you really get a different type at runtime that has an extra Boolean. It's a struct that has an extra Boolean next to the nested value that says whether it's null or not. And we can't do that, or we could do that here, but then we'd be binary breaking the whole world.
Right, which is probably not a good thing.
So we don't want to change what it looks like at runtime. So instead, we have a compile time illusion, like an erase type, a thing that only happens as
exactly that thing. How many of you are Java developers or have been Java developers in the past? Mm-hmm. Okay, a few. So you know how Java generics aren't kind of real? There's this whole type erasure thing, and you can't tell the difference at execution time. Do you know who was at least partially responsible for that? Yeah, so nullable types being sort of a compile time only thing, not so surprising really. And it's a little bit like we already have...
It's all about the...
all about the blame game. We already have something like that with value tuples. So C# tuples from C# 7, where you can give them different element names and things, but that only exists at compile time as well. And the compiler can help you with it, but you need to understand the difference between what's going on at compile time and what's going on execution time. You probably ought to be more familiar with that now than 5 years ago.
Right. And we could have made other choices if we were starting from scratch with if we were building C# today. But here, we feel like for this feature to be useful, there are some choices that we have to make design-wise. And one of the choices is that it has to be It has to be binary compatible. It has to be runtime compatible with whatever code you had before. It has to be that you can just turn on the feature, and then you can add nullability annotations in the right places and get the, what's the benefit, you say? Well, that's sort of what we're getting to now. If we go back to the program now, the benefit is that you will get compile time calling out of where you probably have a null bug, right? Those places that would lead to those unpredictable null reference exceptions before, you will now get them called out in your code.
Right.
So I now get a warning here where I'm dereferencing something that might be null. It's because I marked the middle name as nullable, and because the compiler doesn't have reason to believe that it's not null.
Right. And sometimes you'll get a warning where you didn't have any bugs before. It's just you couldn't really, the compiler can't tell that you didn't have any bugs before.
Your code might be correct, but it's probably shady.
Right.
Yeah. So and maybe error prone in a future refactoring and so on. So it's good to heed these warnings. And so it is telling me indeed that you're possibly dereferencing a null reference. So what can you do about that?
Well, we could check whether middle name is null and not print it at all.
We could say
you can just check
if p.middlename is null. Do something else, do a shorter version of the write line that just doesn't talk about middle names, like that.
The desire to run and put braces in.
That doesn't, I'm sorry.
It's fine.
So that doesn't take the warning away, but if I put an else here, then the warning goes away. Okay, so the idea being that the compiler now has reason to believe that middle name is not null here because it's in an else branch of something that checked whether it was null. So that's another sort of concession to C# being an existing language. There are ways that you can check for null that are sort of correct by construction, using pattern matching, for instance, which we can do in a little bit if you want.
Yep.
But that's not how people usually check for null. They ask up here, is this variable null, and then, or is this field null, and then a little later they use the field assuming it wasn't since the test. Right? And that's exactly what's going on here. So in order for the compiler to appreciate and recognize that, it has to do a flow analysis from, you checked up here, we use the result of that check down here to give you a pass on it. Okay, we get what you're doing here.
And it can be a little more subtle than you might think, because for one thing, I tend to think of this as a little bit like definite assignment. So I can't write int I and then console.writeline I. Okay, that's invalid because it's not definitely assigned. And the compiler already does flow analysis for local variables saying, okay, I can see that maybe it branched and each branch assigned something, so then it's definitely assigned. But what's going on here is much more than that, partly because it's not just for variables. Okay? It's not that we're checking whether p is null and remembering that that variable is null. We're saying when we invoked a method, okay, it's a property, but effectively we're calling a method called get_middlename. That returned not null. We'll assume it stays that way because that's the pragmatic way of going. And it can be really hard to reason about because it's not even guaranteed from the type. You could have a non-nullable thing that you're getting from, get from some method, and the compiler may not be sure about that for whatever reason. More weirdly still, you can say, I'm going to have a nullable variable called x, and I'll assign it a non-null value. And do you expect, when I complete this, that there should be a warning? Okay, I'll give it away. I originally expected it to be a warning, because I'm dotting into something that is nullable. But the compiler's worked out, but the value you're assigning is non-nullable. So it's not just the type of the variable, and it's not just variables, and we need to get used to, it may be hard to predict for a while when it's going to warn us. I've certainly found that. And obviously things will be changing at the moment while we're still in preview, but
yeah, but I think this is pretty solid. It's going to be like this. And again, here's this. So if we had just checked nullability of a local variable or tracked that, that would be one thing, and that's kind of safe. But this is actually a little unsafe, that the compiler lets you do that. It kind of shows that there are holes in our analysis. It doesn't guarantee you that you won't get your null reference exceptions. It just gives you a pretty high probability. Because actually, maybe me calling first name here after the test actually mutated the object and turned it into a nullable, made middle name null.
Or maybe it's just, so when I give C#8 demos on my own, I almost entirely show corner cases where we can break the compiler, because that's what I kind of like. And I tend to give a property that if datetime.utcnow.seconds less than 30, return null. Otherwise, return greater than null. Return some non-null reference.
Right.
And then, sometimes it'll see a non-null value and then go, OK, I'm fine, and then get a null one and go bang. Sometimes it'll get a null thing and then not even ask the second time when it would have got non-null. But basically, we'll assume, or the C# compiler is assuming that people are writing sensible code.
Yeah,
and that's not always going to be the case, but often
it
is. Yeah.
So the idea here is, so this is just to show that there's lots and lots of code out there already that is null safe by checking a property and then using that property, right? And that's a super common pattern. And if we were to warn on that, because somebody might, another thread might, or some spurious ill-implemented property might have changed, then we're not doing you a favor. We're calling out all kinds of false positives in a sense that technically they might be unsafe in corner cases, but in practice they're not. So the feature is very much shaped by what's already there, what's already common, and trying to give the right trade-off between having lots of safety against nulls, but at the same time recognizing most of your null-safe code as null-safe.
Yeah, so it's a different kind. The thing I think that it's important to understand is this is a different kind of type safety. It's not sort of, I guarantee I will not let bad stuff happen. It's kind of, looks good to me. And that takes a little while to get into that new mental model. And hopefully we'll talk a bit later on about new mental models that the C# team want us to all learn. It does strike me, do you remember when we talked in Copenhagen and talked for like 3 hours or something?
Yes.
We only have 1 hour now, and it's 22 minutes past already, and we weren't going to spend long on null. We should probably move on.
That's what I've been trying to lead up to it for a couple of minutes now. So we do have a nice little conditional in here.
Right.
And so I think that's a good opportunity for talking about patterns and switch expressions.
Let's pattern match, yeah.
OK. So another conditional construct in C# is the switch statement. It's probably half a century old syntactically. It was inherited from language to language. Java copied it from C++, perpetuated it from C. Java copied it from C++. We copied it from C++.
I was intrigued by the diagram yesterday that showed C# coming from Java, C++, and Pascal, was it? And I remember the
Delphi.
Delphi. I remember the document that sort of introduced C# before there was a C#1 spec that said that C# was the product of VB and C++. Never mentioned Java in the entire thing. And it's like everyone in the industry going, you're doing Java, aren't you? You're really doing Java. Anyway.
So we could do, instead of this if-else, we could do it as a switch expression if we wanted, or a switch statement if we wanted to.
Yeah.
But it's also a good opportunity to show the switch expression, which is a syntactically slightly less heavyweight construct, which is, you take an expression, you switch on it, you have various other expressions as the possible output depending on whether patterns match, and the one that wins decides what's the result of the whole expression.
So what can we do? That's the sort of language way of saying it. From the human way of saying it, would you like to feel smarter? Yeah? Would you like to feel like F# and functional programmers? Yeah? Switch expressions are a way to get that. I found that with expression body members in C#6. It's like, I can now feel like I'm 5 IQ points smarter. And switch expressions just do that for me again.
Right. So we could do something like string output equals, we could switch, well, if we want to ease incrementally into this, we could switch on p.middlename.
Right.
So we could say p.middlename switch, something, switch, and then give a couple of cases here. And the way you give cases in Uh-oh. Preview. And so the last time this happened to me, I actually had to kill and restart Visual Studio. I am so sorry, guys.
So while that's going, we can describe. I can describe what the syntax will be. So in a normal switch statement, it's switch and then the value, and then open brace and a load of case labels. So you have case, foo, and then colon, and maybe some code or maybe multiple case labels. We'll get my feature request to Mads in a minute. And within each case label, there are a bunch of statements and then usually break, unless you're returning from the method there. And you have a default, potentially for if you don't, what you want to do if none of them match. And before C#6, do I mean 6 or 7? When did we introduce pattern matching? When did you introduce pattern matching?
7.
7, OK. So before 7, the order didn't matter in most cases because only one case could be matched anyway. So C#7 introduced pattern matching in switch statements as well as in is expressions. And so you could have patterns. So you could say, I will match an object O when it's an integer n, and introduce a guard clause saying when n is greater than 5. And good stuff like that. So we ended up having a pattern as the case label instead of just a constant. And every constant is a pattern in itself. So now having all those cases and things, whoa, ended up being...
It's getting worse and worse.
We may need to plug in my laptop after all, which doesn't have this demo code on. It has different demo code. We may need to... Is someone taking a screenshot, please?
Okay.
So what we're going to have instead, we don't want to have case labels. Everything in a switch expression is going to be a case, so why would we bother having a keyword saying it? And instead of being this weird block that contains other things that don't have to have their own blocks, which introduces unfortunate scoping rules, a switch expression is expression, switch, and then a list of cases, a comma-separated list of cases. So usually when you're converting a switch statement to a switch expression, you switch round the switch keyword and the value, and you can get rid of any brackets around the value, and then remove case from everywhere. And instead of case, then the case thing itself, colon, instead of that colon, we have a fat arrow, goes to, because it's the idea that this input produces this output, this input produces that output. And they're comma separated instead of semicolon, so you usually replace every break with a comma. You can get rid of, if you were returning, my most common thing is I've got a method that is trying to get a value of something, and it's going to return in every case. And you can get rid of the return statements just as you could in lambda expressions. Okay. And the final thing is that there is no default keyword for switch expressions. Instead, we've already got a pattern that matches everything. And by the time we're there, usually we don't care about what the value is, so we just use an underscore, which is a special sort of, I don't know whether it counts as a contextual keyword. Woohoo!
I got my curlies.
But it just means we discard whatever's in there.
OK, so null, fat arrow. So I'm really glad that you joined this talk. Now I can show what Jon just carefully took a lot of time to explain. So null, I can then return a given string. Right? Let me, if I have another paste area somewhere, it won't go wrong. Right? If I paste up here, and I can steal that string, the string out of there, and hopefully paste it in. There we go. No. Oh, no. I don't think we're showing the switch expression. OK.
Switch on line 22.
What's that?
You pasted back line 22.
Oh, that's...
The deadly switch.
OK.
Okay.
We'll probably move on because...
Yeah.
Oh, but the pattern match.
Yeah.
Oh, but the pattern match.
It worked the other day. I'm on the internal preview. I shouldn't have. I should be on.
If I type it instead of you, is it more likely to work?
Maybe.
Don't you just want that to work? We're just
so sorry. Yep. I don't have the latest VS Code. Yeah, nice though. Okay, we're going to give up on showing. Now, what's going to happen is I'm going to get a million operations.
So I can say that here's one I prepared earlier, as it were. If you go to the Nodatime GitHub repository, which is predictably github.com/nodatime/nodatime, and look at the commits from the last couple of weeks, one of them is switch expressions, and I think I've helpfully said, use switch expressions from C# 8. And the good thing about that is not only do you get to see it without crashing anything, but you also get to see that this is actually genuinely useful. And I've got a bunch of commits for Nodatime implementing nullable reference types. You may notice that CI is broken for Nodatime at the moment on AppVeyor, because AppVeyor only has preview 1 of Visual Studio 2019, and I now need preview 2. I'm expecting that to sort of sort itself out in a week or so. But Travis is working, so yay. But you get to see all the good things about it. You also get to see that the commit that's currently on there that I'll be pushing on the train this afternoon is docfx doesn't like switch expressions at the moment, and it looks like it stops parsing when it finds one, so I've got a commit that just moves a method that's composed of a switch expression from the top of a file to the bottom of a file so that all the public members between I can actually see.
At least gets most of the way.
This is a very temporary hack. It will also mention the feature request that I have for Mads. So one of the nice things you can do in switch statements is you can say case 1 and case 2 and case 5 all go to the same thing. Now, if you have a list of patterns, you can do 1 goes to compute value, 2 goes to compute value, 5 goes to compute value, but there's no current way, or at least there wasn't last time I asked about it, to say, do you know what, I want a pattern that matches any of these things. There is a GitHub feature request for it that has had some traction. What's the current thinking? Are we likely to get it in 8?
Doing the what, sorry?
Having multiple patterns that are sort of awed together so that I can say, if the month of the Hebrew calendar system is this, this, or this, then the answer is?
That is not currently going in.
OK.
I think there's some debate as to whether it's a good idea.
So that's a promise for 8.1, yeah?
So now I'm going to do it again, but I'm going to do it with MT. No. OK. Yes, yes, whew, came back. No.
Nope. Oh.
Oh my God.
Maybe it's because it. Oh, yeah. Let's just.
Okay, we'll move on from here. We're not going to do the that part.
We can move on to code that won't compile. Ironically, next in my little agenda here is target type new.
Yes.
How confident are we that when writing code that we don't even expect to compile, it won't just crash Visual Studio?
Well, that could be surprisingly. That could be much better.
Yep. Yeah. So expect the red squigglies in this bit are intentional.
Yep.
Try killing your console window too, because I think the bugger's attached to it.
Oh.
Could be.
Huh?
Yeah.
OK.
All right. One thing that is, that's annoying, that's repetition, is I'm having, in my array here, I'm having to say new person all the time. Person is a short type name, but sometimes you have generic types or things that are, and you just said, you're declaring a field of type iDictionary of something to something else, and now you have to
equals
dictionary,
new
now
dictionary.
Equals new blah, that whole type once again. So a nice little feature that's mostly just a convenience is allowing you, and I'm really scared about typing anything in here, but allowing you when the context is given, which it isn't right now, but it could be, allowing you when the context is given to simply say a new without the type. Okay? Just give the constructor argument, and then whatever that is assigned to, the context, the type target, if you will, gets to decide what you're newing up. So you could pass that to a method that expects a parameter of type person, or assign it to a field that has that type. So
from
that's something that's
language nerd perspective, I find this kind of thing quite scary because this is introducing another kind of expression that has no type. So we already have a few of these, like the null literal does not have a type. It's sort of, well, it'll do different things depending on how you're trying to use it. And lambda expressions themselves don't have a type. If you have a lambda expression that takes no parameters and says console.writeLine, whatever, then you can assign that to action, but you could also assign it to any other delegate type with no parameters and no return value. And this is another kind of expression, typeless expression, and that raises interesting questions when it comes to type inference and overlay resolution.
It does, but most of those interesting questions we've already had to deal with because of those other examples you show. So we decided, you know what, we can do this and not significantly complicate the language, and in many cases it's completely given what you're doing up. It's a nice convenience. So, so it's going in hopefully in the next preview.
So you demonstrated sort of it's mildly useful, but the really nice example is if you sort of want static var people equals new list of person stuff. And this is not that.
But it's as short as.
But it's sort of, if we just, instead of that, just do that. And, will I be able to do this without any round brackets, or will I need the round brackets?
Yeah, you can do it without the round brackets if you have an object initializer instead. Yeah.
And then, and presumably it'll infer that as well.
I can say yes to all of these. It's not running right now.
So you still only have to put it in one place. Now, interestingly, that works if I definitely want the same concrete type, the actual type on both sides.
It's limited in the same way
that
var is, just in the opposite direction. Right. Var can't give you the interface that the concrete type implements or something like that. Var gives you the most specific type it can.
And presumably there's no idea of, well, the default implementation type, I'm not trying to mix features, default implementation type of I list of t is list of t. So if I declare it right.
Not.
OK, that's fine.
Because that would, now it would get complicated, right? This is right now it's just a shorthand, and that's how it's going to stay. OK, but I'm going to erase this because it doesn't compile, and hopefully we'll get to actually writing something that does compile and doesn't crash. Time to talk about async?
Yeah.
So.
Hang on, we were going to do indexes and ranges.
We forgot about those.
Fun. Yeah.
That's why it crashed. OK, so yeah, that's right. So we have an array up here, and so that's a good example to demonstrate features that are.
Do you want to kill line 25 before bad stuff happens?
Yes, line 25 is still there, isn't it?
Sort of line of doom.
Hopefully, killing it isn't what causes the problem. So we talked about various ways that we could improve things working with indexed things. Right. It's sort of vaguely inspired by the arrival of span into the language.
How many of you have used or at least looked at span of t?
Which is okay.
You're going to want to know more. It's going to be important, I think.
Maybe it might not be for everyone, but it's essentially the idea of being able to represent a chunk of memory without sort of representing the whole chunk of the memory, right? So, for instance, it can be a window onto an array, but you can index it and manipulate it through the span.
Yeah. So an abstraction over. Yeah. I can get some stuff and I can take a slice of that span. Yeah. And good stuff.
So, but there are other things as well, and arrays are a good example of it. But there are ways in which it's a little annoying to work with an array. For instance, let's say I want to display the last person in the array. Okay, so we say array of people index. Now I have to. What do? I have to say people dot.
And it's an array, so it's length rather than
length. I have to remember what the thing is. Well, I got IntelliSense -1.
Okay.
And sure, I can do that. And I mentioned people twice. If it was a result of some computation, I would have to grab it into a local variable, so I can mention it twice. And
Yep.
you know,
And you could use .last. We could just linkify the whole thing.
sure.
But it's, that only works for last.
That one works. What if I wanted the second to last and so on?
Right.
So we have a new. You can sort of call it a shorthand that you can ask from the end instead. So I can get number 1 from the end. Gives me exactly what we saw before. So that's essentially an index that means length minus this number. Okay?
And when you say it's essentially an index, the type of that expression is index.
It is in fact a new type called index. So we could say index hat 1 here. Index I equals that.
And this is a new type in .NET Core 3.0, but presumably there'll be a NuGet package so that if you're using older versions of .NET, you could bring in the NuGet package and the compiler will just say, oh yeah, I know about that type.
I'm sure there will be such a if we don't put one out, it'll be out in 5 seconds anyway.
Yeah.
You will. So it's a first-class thing, an index that knows whether it's starting from the beginning or from the end. So you can compute with the indexes and then apply them later if you want to. That's not always what you want, but sometimes you do. What's more is that you can also express ranges. So I can, for instance, say that I want to go from the second element to the second to last element with a range expression like this. Okay? Mm-hmm. So this is really a range that also has its own type. I can say range R equals this. And a range is 2 indexes. It's one for the first element of the range and one for just beyond the last element of the range.
So inclusive lower bound, exclusive upper bound, if you want to think in those ways. Which means it's slightly confusing because if you take people hat 1, that gets you the last one, whereas people 1 ... hat 1 doesn't include the last one. So you need to remember that it's exclusive, which most things already are. If you're using substring, for example, substring 0, 5 doesn't give you that character with index 5. It gives you the first 5 characters. So it's
it's trying to be consistent with what's already there, but it is a little confusing that it's exclusive at the end. It does make for very simple math, though, right?
Yeah.
So essentially, this is the way you slice off one at either end. So we get the 3 middle people, and if we run that, do I dare? I just want to see if there's anything dangerous in here. If we run that, we don't get John and we don't get Tess, but we get everyone else, right?
Woohoo!
Tess is there because we displayed her explicitly on the line before.
Okay.
So that's good for manipulation of various indexed various indexed collections, including spans, right? So one of the things you can do with a span is you can get a subspan and a subspan of that and so on. You can chunk them down, and they're all like pointing to the same. The part of span is they're pointing to somebody else's memory. They're all pointing to the same memory.
So in particular, in this case, we've got an array, and we're applying the index operator, so the indexer with a range, not an index. So if you hover over people 1 ... hat 1, what's the type of that?
Where do you want me to hover?
There. Oh yeah. Well, let's just assign that to a local variable and see what we get.
Yeah, you want to borrow it.
Yeah.
So if we
because you may be wondering, is that going to create a copy of the array? And I'm hoping it's not. Yeah, question.
Was it considered to use a Python like -1?
Yes, very much so. Who asked? Sorry, where? There. It was, and the problem with -1 is that that's fine, except for at the end, right? If you want to express a range that go all the way to the end, then you end up having to say -0, which is the same as 0, which doesn't mean the end; it means the beginning, right? So Python has a math problem, and they have that means that you have to sort of special case the end when you're going all the way to the end, as opposed to when you're going end spaces from the end. And you have lots of, it's one of the annoying things when using an otherwise nice feature in Python is to have to special case this going all the way to the end versus going almost to the end.
And it should also be pointed out that these two indexes are entirely independent. So you can have, I want to go from 3 from the end to 1 from the end.
Yeah.
Or even 3 from the end to 5 exclusive, 4 exclusive. So still getting rid of the first one. And that's not saying I'm going to wrap round. It's just saying, well, I'll take, you're starting at this index that happens to be from the end, and you're finishing at this index that happens to be from the start.
And of course, like every index operation, if you apply it to a collection where those numbers don't make sense, where they go out of bounds, you get
the range itself is still valid, and the type of that hat3 ... is range, which is a new type again, and you can create those range values by calling new range or whatever. But the range itself does not know about people. You could apply the same range to multiple collections, and sometimes it'll be valid and sometimes it won't. It's just its own little type. And I assume they're structs, actually?
Yes, they're structs. Yeah.
So we were looking at what the type of A is.
And
it's never used, but...
It's an array. And you might wonder, hey, that can't be the most efficient thing.
Yeah.
And it isn't.
Right.
Like we have to copy and create a new array. So when you apply the range indexer to an array, you get a copy.
Oh, so don't do that. Show us what we should do.
So what you should do is you should go through spans instead.
Right.
So you could say people.asspan.
So that's not creating a copy of the array, it's just creating a span that refers to the array.
Yes, it's creating a window onto the same old array, and then when you apply the range indexer to that, then you get another span, obviously, but but of course no copying is happening.
And the cool thing here,
span already didn't have its. So the principle here that we discussed it a lot because it's not very efficient to copy part of the array out. But the reason we ended up with this is that it's a good principle that the slicing indexer, the one that you apply a range, that it returns the same type as it's applied to. So that will also be the case for string, even though a span of character would be more efficient. That's going to be kind of surprising to get back. Right? You do get a substring. So it works like substring. You really need to be
aware of this in order to use it, use it effectively. And
on big arrays, at least, right? But small arrays, who cares?
Yeah.
Depending on the situation.
There's an assumption to say, I'm using small data now, therefore it doesn't matter how inefficient it is, and then later it becomes big without anyone going over those design decisions again. But this span, to sort of prove that it really isn't copy, here I've now taken, so we're taking a span over people, then taking a slice of that span, and then assigning a new value into part of that span, and then we're going to display this is creating a copy of the array. So if we'd taken this as a local variable earlier, it would have caused different behavior. But hopefully, if we now run this.
For you? There we are.
OK. And now it's a bit small, but you can see Amy Kapanek as the third entry here.
Yeah, so through the span, into the other span, into the array that was then copied.
Yeah, so it's all sort of this transparent thing with no copying going on.
See the result of that.
Printing test to start with is confusing everything even more, but but yeah. So the idea is there's this sort of memory transparency.
But that's not what we're here to talk about.
It's like no, but really cool.
So I do want to get briefly to talking about async streams as well.
Yep.
And then for the last 5 minutes or so, we can talk about the future.
Yes. Let's do.
The beyond the future. So let's see. How do we do this? Let's create a little method. Let's do a local method that's an iterator. Okay. To start with, let's do one step at a time. I'm going to write a method that returns an IEnumerable of person. And it's a completely trivial method. Let's call it getPeople. That just runs through the array and yields them out.
Yeah, well, why don't we do yield new person? Yeah, so we've got more than one yield statement. Unless that's
just more writing. I'm too lazy for that. Sorry. So for each var p and people, yield p. Okay, and maybe
Print that we've done it.
what's
Oh,
that?
yes, yield return.
Oh, yield return. Sorry, yeah, I don't know my own language here. So I don't do much C#. I'm sorry. So we have a method here that gets the people, and then let's remove some of this index range stuff because it confuses me a little. Then we can say for each var person in get people, print them out.
Yep.
Okay? So nothing new here, it's just an iterator. However, what if I wanted to, let's say we're emulating some service where things are coming down over time.
Pretty
right?
much anything over a network.
As the people are signing up for my service, I get the person object. So I would really want to await task.delay of some time, let's say 500 milliseconds, okay? And I want to do something async. Now, of course, I can't await because it's not an async method. Well, let's make it async. Okay. Now it's async. Of course, you can't return an enumerable from an async method. But what you can return now is an async enumerable. So you can see that's one of the options here, which is a new interface that is the asynchronous version of enumerable. Okay, so all the things that you've been able to for each over all the time, there's an async version of that. I wonder what we could do with that one. So let's just to be nice, let's call it get people async, because I think we probably want to have the right suffix there. So now the errors have gone away. So apparently I have a valid async method here, to a first approximation at least. But now, first of all, there's nothing called get people. But I'm going to get a different error saying I can't for each over async enumerable. It's not an enumerable. Wonder if I can.
And it doesn't contain get enumerator. We already have
Yes.
sort of pattern-y things.
But I can await for each it.
If we make it a static method, an async.
Yeah. So now, I'm fine to await it, but I have to make the main method an async method. But luckily, there's even a refactoring for it, I think.
Ooh. Does it
See?
tell the project? Oh, you're probably in
Make
C#
method
mode
async
already.
And now, as of C# 7.2, I believe it was, or 7.1, main methods can be async. And so now that all works out. So essentially, we have an async version of streams that can represent stuff that comes over the wire to you or gets computed over time or whatever. So real-time streams. And we have language support for producing them out of iterators that are async, and language support for consuming them with an await for each.
Now, this is not the same async enumerable as we're familiar with from Rx, is it? Or is it now?
It is essentially the same in the sense that Rx, or IX rather, the interactive framework.
Essentially the same. So
No.
does that mean that my libraries that are currently returning?
It means that we have changed the interface a little bit over what they had.
Right.
But IX, which is a community library that provides link over asynchronous streams, is actually going to adjust to we're putting the interface in as a core interface, and they're going to adjust it so that it works.
Right. But it does mean if you have libraries that currently return the IX one, you'll need to work out what to do next.
Yeah.
Which will be interesting. So I'm in that position myself. And,
then you can blog about it, and everybody else will have an
probably
easier
will.
time. So that's async streams. And
Cool.
that sort of completes the async picture, and it's also, and the async picture at large is the subject of a talk tomorrow that I'm going to plug, which Bill Wagner is giving. So if you want to be reminded of all the goodness of async and all the things to be worried about, including async streams as I understand it, go to that talk tomorrow.
And as well as async, so as well as await for each, there'll be async using, so that you can asynchronously dispose of things.
It'll be await using, yes. So there's an async disposable as well, and you can await using an async disposable.
But we won't bother showing that now because we're running desperately short of time.
Well, desperately, I don't know. A little short. So that's essentially what we were able to show, which was a little less than I had hoped for. There are things that, beyond the things that don't work properly in the preview, there are things that aren't there yet at all. We showed one of them just by mock typing it. But the other one that is a major feature is the default interface members, which will be in one of the next previews. And the idea here is that, and this is something that we squinted a little at Java here, I have to admit. Occasionally that happens. Such as when you're designing a new language 20 years ago. You squint a little at Java. So this is essentially to address a problem with interfaces, which is you can never evolve your interfaces. Because they're a public contract that not only has consumers, but also producers, right? They're implementers of the interface. And if you add a new member to your interface, you've just broken all the implementers. And default interface members are primarily there to address that scenario. So the idea is you can add a new member to an interface as long as you provide a default implementation for it so that all the existing implementers aren't broken. They just get that default implementation for free.
Yep.
It continues to work the same way. And so an example here is I have an existing implementer of my iLogger interface. I add another overload of the log method. And as long as I implement it right there in the interface with so that's a method body in an interface, which some people find offensive, but it's what the feature is about. It's necessary for the feature to work. I'm sorry, but the console logger will continue to work, and if people use it through the interface, they can now call the new overload of log.
Only through the interface. So my understanding is this is effectively explicitly implemented.
It gives you an explicit implementation, which means it's not available on the console logger itself. It's not it doesn't change its public. That would be very breaking, right? Yeah. Because that could change overload resolution and everything when you use it.
Right.
So it doesn't become visible on the console logger, but if you use it through the interface, now instead of being broken, it actually.
But if later on someone thinks, hey, I can do a more efficient implementation, yes. Then you can just add it. It implements the interface method, and all is well.
Right.
Presumably you are in trouble if you've got a public int log exception X, then people are only going to see one version via the interface, they'll only see the other version via the class, and we just have to live with that.
That's all. You can already get into that today.
Yeah,
that's not a new problem. So, but essentially, if you choose to implement the interface method yourself, there's nothing different about it. It's like today. It's just that if you don't, then it gets implemented for you.
So this becomes a little bit more like an abstract class, but you still can't introduce fields. But I suspect certainly it would mean that a lot of the places I use abstract classes at the moment so that I can add stuff later on, I would be able to use interfaces. At least I would if I were only targeting .NET Core, because my understanding is this requires runtime support.
This is only going to, well, .NET Core, or the Core CLR, and Xamarin, or the Mono stack.
Okay, right.
So this requires new runtime support, which is actually a first in like a decade. Essentially since generics, we haven't added a language feature that required new runtime support.
Even dynamic, which kind of blows my mind, that dynamic can be implemented entirely within frameworky things.
It might have been better if we did, though. But this means that this doesn't work. This doesn't down target, and particularly it doesn't target the framework currently. The CLR, the classic CLR on desktop doesn't support this.
There is hot discussion around whether this should be in Net Standard 2.1 or not.
Yeah. So it's interesting. Like it's giving us, and we're using this as a bit of a a canary in a coal mine for what does it mean for us to start doing runtime changes again and doing them only in some of the stacks. Like how does that all work out? This is sort of our first foray into that, and it means that if this goes well, we will be open to doing more features that are implemented in the runtime and evolving the runtime along with the language, which, if we had done that all along, many things would probably have been better. So. But
equally would have had a worse backward compatibility story in some cases, and there are trade-offs.
Yeah.
Life is hard.
And that's one of the reasons why we can now do it, because .NET Core has a better story for sticking with the older versions, so. Yep.
Can the log method, telemetry logger .log with an exception, can that be an explicit interface implementation?
Can the implementation down here in telemetry logger be explicit? Yes, of course. Yes. If you can do all the same things as if it didn't have its default implementation.
And if I wanted to call the default implementation from another implementation?
30 seconds left.
OK.
So I just want to quickly mention
Oh,
more things on my slides. Quickly want to mention some things that we are thinking about for the further future, maybe C# 9. One is some notion of records, by which I mean a drastically abbreviated way of creating classes for representing data. Okay? So it might be that they have a syntax something like this. And what that would really mean is that you get a constructor and a deconstructor and value-based equality and hash codes and all that stuff, properties. So it's sort of a way of very concisely describing data, which functional languages are good at this. Things are more verbose in an object-oriented language, and that sometimes okay, I know exactly what my data looks like, but I'm going to spend the next day and a half just writing the class declarations.
Yep.
Maybe you could do that. Maybe you could turn that into half an hour. So we're looking at that, and in connection with that, maybe also looking at discriminated union syntax, where you can describe a group of related types in a very concise way.
Which, when you combine with pattern matching, is then kind of more interesting, and a lot of these features all build and work together. I can't wait for this. I have been waiting since C# 6 or whenever, but I would far rather have it right than early.
Right,
So-
and there's some ways in which it is a little hard. One thing we would like to capture is that it doesn't necessarily have to be ordered. It doesn't necessarily have to be that you give things in a certain order and they're always deconstructed by that order. Maybe you want to just describe your records as having these named entities, and maybe you want to be able to create them using object initializers, even though object initializers today require you to mutate an already existing object. Maybe we can make it, either with or without runtime help, make it so that you can use an object initializer even to initialize immutable objects. Right? After all, it's part of the constructor syntax. Wouldn't it be nice if it could actually help construct the object?
Absolutely.
And so something like that. And maybe even for immutable objects, having a feature for non-destructive update, as people call it, where you can create another object just like the first one, except with these things changed. So for instance, I could create John Galloway by taking Jon Skeet and just changing his, creating a version of him that has a different last name.
And this does not change my name, importantly.
And there's still a Jon Skeet, so, that's the nice thing is that we would still have you.
Well, nice for me anyway.
Yeah. So, so that's stuff that we're actively researching now for a future version of C#. And then there's more crazy stuff, but we're over time, so I think...
so in summary, if you want to know about C# 9 and get ahead of the curve, learn F# now.
That's true for this stuff. That what I won't get to is a little more different.
Yeah, and there's there is no disrespect meant in saying that the C# team is borrowing from F# heavily. This is fantastic for all of us. It's a really, really good approach that seems to have been working very well, taking things slowly so that we make sure that everything is still feels like C#, just feels like C# with a little bit more of a functional bent, as it were. And it's fantastic.
And I want to
how
be,
things are evolving.
I want to be clear that the borrowing goes both ways. Like
Right,
we have,
okay.
We have tuple member names now, and Nullable in F#, Nullable is going in there, and so on.
Oh,
So,
cool.
so we're kind of co-evolving, and that feels good. Yep.
Cool.
All right.
Thank
We're
you
out of
very
time.
much.
Thanks.